guys, in your notes, how about somebody recall what the midpoint formula was for me? Somebody want to shout that out to me real quickly? Okay, go ahead, Taryn.
x1 plus x2 over 2.
All right.
y1 plus y2 over 2.
Okay, so yesterday we said with the following right here. First of all, the thing I want to point out to you is this. In example A, when we looked at it yesterday, we had both of the, what am I highlighting here? We had the endpoints. We had both endpoints. We said, you know what? If I have both endpoints, our job is to find the midpoint. When you have both endpoints, that midpoint formula works out really well. That midpoint formula works out really well. Now, what we had said yesterday was this. The midpoint became the following. We called point A and really our point 1, and point B was really point 2 here. So what do we put in for x1 plus x2 up top?
Negative 8 plus 5.
-8 plus 5, and what do we divide that by, Mary?
Divide by 2.
And now what was your y1 and y2 values?
7 plus 1.
7 plus 1, divide that by 2. What did we get for a midpoint coordinate, kiddos?
Negative 1.5.
-1.5
And 4.
and 4. So that was the midpoint right there. And we looked at that graphically yesterday and confirmed that. And we said, yeah, that makes sense. Okay? So the first case they're going to talk about in terms of finding the midpoint is when they give you both of the endpoints. Okay? Now B is a bit different. B is a tad bit different. And I'm going to look at this a couple of different ways. Okay, we can still use the formula, and that works great. But I also think there's a better way to think about this mentally compared to doing it algebraically. So in part B right here, instead of finding the midpoint, what do they give you? What do they give you?
They give the midpoint.
The midpoint of PQ is what, kids? 2 comma -3. And then it says the other endpoint, one endpoint is 4 comma 1. Find the other endpoint. So let me show you how this is going to look. All right. You guys remember those points. So instead of giving 2 endpoints, they're giving you an endpoint and the midpoint. You need to find the other endpoint. All right. So let me get a graph here. Okay, what was the midpoint they gave you, kids? In example B, what was the midpoint? What coordinate? 2, -3. So write 2 and down 3. Okay. All right. So this point right here is going to be the middle of some line segment. That point right there is going to be the middle of some line segment. What was one of the endpoints here? 4 comma 1. So write 4 up 1. Okay. What endpoint was that? What variable? Was it P? Okay. Okay, so it looks like to me if I drew a segment right in here and hit this point right here, that's the midpoint. So it looks like to me that other point's got to be down in maybe somewhere in this area somewhere. Would you guys agree that the other endpoint's got to be somewhere down in this area?
Yes.
Okay, a couple ways to think about this. Okay, to go from P to M, guys, to go from P to M, how far down do you go? How many units down do you go?
4.
4. And how far to the left do you travel? 2. So if I did that again, wouldn't that take me to the other side of M, that same pattern? I could go down 1, 2, 3, 4, and over 2. Looks like to me the coordinate's going to be what comma what, guys? 0 comma what? Looks like to me that new endpoint is going to be 0 comma -7. All right. Now I want to show you how to get that algebraically. It's pretty simple. Okay. All right. Back to your notes. part B. Here's the deal. In example A, we had to find the midpoint, didn't we? In example A, we had to find the midpoint, right? But in example B, don't they give you the midpoint? So for the midpoint, what could I put in right away for midpoint, kiddos? 2 comma negative 3. I'm going to say that point 2 comma negative 3 right there. That point 2 comma negative 3 is equal to the following. It's equal to, all right, my x1. Do we have the first x value up here, kids? It is what? 4. So it's going to equal 4 plus, do I have the second endpoint up here, guys? Which is q. Q is what we're trying to find. Q is really going to be that point x2 comma y2. That is what we are trying to find right there, that other endpoint. So I'm going to say that this midpoint is 4 plus x2, and then divided by what by formula? 2, comma, let's do the y values. What's the y value of the first endpoint, kids? What's y1? 1 plus y2 all over 2. We're left to find x1 and, I'm sorry, x2 and y2. All right? So here's the situation. Here's the situation we run into. Basically, this mess right here on the left, this 4 plus x2 divided by 2 has to equal what value? 2. Here's how you solve this. Here's how you solve this. What we're going to do is we're going to take this and this, the x and the 4 plus x2 over 2, and set them equal to each other. So we're going to set 4 plus x2 over 2 equal to 2. All right, help me solve this here quickly. We have to find an x2 value that would make this statement true. So the way you do it is the following. What's 2 times 2? 4. Now subtract that 4 out. Where are you at? 0. So 2 times 2 is at 4, and then subtract that 4. You're at 0. So what's that make x2 here, guys? 0. Okay. So the x2 value right here is going to be 0. All right. The x2 value right there is going to be 0. And if I look at my graph right here, when we drew the picture right here, what was the x value at that point when I drew it? 0. So is that confirmed? Okay. Now this is the part that's maybe a little more difficult, and maybe I would suggest, you know what, maybe sketch this as well just to see a visual. Well, let's do that y2. I'm going to do the same thing to try and find y2. Right here, gang. Right here, gang. This mess over here on the right by formula has to equal what value? Negative 3, right? So we're going to take 1 plus y2 all over 2, and that has to equal negative 3. So help me with this. We've got to get this 2 out of here. So we're going to multiply negative 3 and what? 2. Negative 3 times 2 is negative 6, isn't it? And then subtract 1 more to get y2 alone. Negative 6 minus 1 more, where's that land you? Negative 7. So the y2 value is negative 7. Therefore, the coordinate q that we're looking for is the point 0, comma, negative 7. Okay, 0, comma, negative 7. Now, didn't we already prove that graphically already? Okay, so you have this kind of a mess right here. I'll call it, for lack of a better term, a mess. You have to use this right here when they give you the midpoint and an endpoint. All right? Midpoint and endpoint. Try and find another endpoint. That's kind of difficult. Right? So midpoint formula. First things first. Do you have this down? Do you have that down? Okay. All right. These 2 examples. Do you have what you need here? Any questions about that? All right, let's jump into this last page here quickly, and then I'll get you going on some work. Everybody have what they need? Yes? Okay. So on your notes on the last page, and this is the last thing we need to start looking at, guys. Using what we call the distance formula. Okay, distance formula. Let me ask some questions here. What's the length of this line right here? Whoops. What's the length of this line right here? And how do you know? What's the length of that line segment right there? 8 units. It's horizontal, so I can just count it and reference it by the number of boxes there, right? How about the length of this line right here? You guys agree that that's a distance of 4? So here comes my big question. I can count that because it's vertical. How about this line segment right here? Is that line segment vertical or horizontal? No. What is that, a segment in the plane? It is, isn't it? Can I just count the length on that, or do we probably have to do something different here? You're probably going to have to do something different. If I can't count either left to right or up and down how many units that is, then we're going to have some kind of a formula to figure that out. Here's the deal, guys. Let's just pretend this. This is your house. And this is the school right here. And this is a road. You can take the red road to school, or you can take the blue road to school. You're running late, so which route are you probably going to take? Why the blue route? Because you guys have always heard before, the shortest distance between 2 points is a straight line. If I go this direction and up, if I go 8 units and then 4 units, isn't that going to be more than just getting on the blue path and going there? If I said, hey, McKenna and Britton are going to run a race, right? McKenna and Britton are going to run a race. And I'm going to say that you guys are going from H to S. And I'm going to say, McKenna, you get to run on the blue route. Britton, you have to run on the red route. Who has the advantage? Why? It has to be shorter than the 8 and 4 put together. So what is 8 plus 4? 12. So we know the distance that we're going to run is going to be shorter than 12. Okay? By the way, anybody know how to solve that right there? Yeah? Not quite. I've got a nice little formula for you. Are you ready? Are you ready?
Yeah.
Okay. This is a cool formula. I like this. All right, John. I should have known better, huh? Yep. Okay, distance formula here. You can find the distance of any line segment in a coordinate plane with the following formula. D equals, here we go. It'll be, in parentheses, x1 minus x2. You guys know what the x1 and x2 part means already, right? All to the second power plus, what do you think the second part is going to be of this? If the first part's x1 minus x2, what do you think the second part's going to be? y1 minus y2, all to the second power. And then your last step, after you've done all that, take the square root of that mess. Big long formula there. Make sure you've got it written down as I do. Let me ask this question as you're writing it. How many of you have heard of Pythagorean Theorem before? How many have heard of a squared plus b squared equals c squared? That's all this really is. Okay? That's all this really is. All right. Here's the situation, guys. It says you've biked 5 miles to the east and then 2 miles north from your apartment to a friend's house. Estimate the distance from your apartment to your friend's house. Here's the deal. I'm going to make a drawing. How many miles east do you go, guys?
5 miles.
5 miles east. And then how far north? 2 miles. So this distance down here is 5 miles. And this distance right here is 2 miles. Okay. Our job is trying to find that distance along a path from here to here. Okay, that's our job, find that distance. Now guys, what's the 5 plus 2 add up to? 7, okay? So I know that yellow route's got to be less than how many miles? It's got to be less than 7, all right? Here's the deal. This is a right triangle right here, all right? You guys have seen Pythagorean Theorem hopefully before where it says a squared plus b squared is equal to c squared, okay? C right here representing what we call the hypotenuse. Hypotenuse. So the yellow part's really that long part that we're trying to find. This is like the C value you don't know. All right. So what value is going to plug in for A and B? What value? 5 and 2. So this would be the same as 5 squared plus 2 squared equal to C squared. Okay. Help me out. 5 squared, kids. 25. 2 squared. That equals C squared. Okay. What's 25 plus 4 add up to?
29.
So C squared is 29. We're saying some number times itself is 29. So the way I find C now is to finally take the square root of both sides. And then C is going to equal whatever the square root of 29 is. So, calculator. I'm going to punch that in. We're going to go to square root of what value? Well, 29. Get the square root. Let's go 2 places. So about how long is C, guys? About 5.39 miles. Okay, about 5.39 miles. All right. Let me show of hands. You should have seen this before. I would hope that you've seen this before. Yes?
Is that after it says square root of 29, what's it say?
Square root of 29 equals the square root of C squared. So that just becomes a C because the square root and the squaring operations are inverses of each other. They cancel. So this says that distance C is equal to about how many miles, guys?
5.10.
About 5.39 miles. All right, so I want to show you how that relates. I want to show you how that relates to distance formula here quickly. And again, you'll be finding the distance between 2 points using that long formula up there. But the thing I want you to understand is what you're really doing is the Pythagorean theorem in a way. All right. So I'm going to go back to my coordinate plane. I'm going to clean this up. All right. How about somebody read that last example that we need to look at here, example 4. Volunteer to read that problem for me. I don't have it in front of me. Who would read that? Yep, the example right there. Find the...
Find the distance between 6, 4, and 9.
Okay, so the 2 points are 6, 4, and... All right, so I'm going to label 6, 4. That would be right 6 and up 4, wouldn't it, gang? Whoops. Right 6 and up 4. That's this point right here. And what was the other point? Okay, so there's a line segment that exists between these 2 points. And again, you don't have this in front of you. So just watch what I do here. Okay, that line segment right there, we need to find that distance. Is that horizontal, left to right at all? Is it vertical? No. So anytime you have a line that's neither vertical or horizontal, then you need to use the distance formula. Anything slanted like that, you need to use the distance formula. So again, this point up here, 6, 4, I don't need to use yellow. That's hard to see. 6, 4. And this is 9, 0. Whoa. All right, we need to find the distance of that line. Okay. Now, I want to show you something right here, guys. And I'm not going to draw this yet, but I'm going to go ahead and just use this formula right here. Okay. I'm going to write the formula down again so I have it on the screen. So the distance formula equals square root of x1 minus x2, all to the second power, plus y1 minus y2, all to the second power. I think it's to your advantage to fill everything in first, okay? So this is my point 1, 6 comma 4, this is my point 2. So let's go with this. The distance of that line equals the following. All right, what are you plugging in for x1, kids? 6. What are you plugging in for x2? All to what power? What's going in for y1? 4 minus
0.
all to the second power, right? So keep in mind, anytime you square something, squaring something will always be what type of a value? 3 squared. 3 times 3. What kind of value do I get out? Positive or negative? Positive. When you square stuff, you will always get positive values, okay? Help me out. What's 6 minus 9? Negative 3. But we're going to take that negative 3 to what power, guys? Second. So this is going to be a 9, isn't it? How about the next part? 4 minus 0. But 4 to what power now? Which makes this a... Okay, underneath that square root, what is 9 plus 16 now? So we're going to say that distance d is equal to the square root of 25, right? Therefore, what's that make your distance? What is the square root of 25? 5 units long, right? Distance is 5 units long. All right. Is the formula rather lengthy? Yes. But if you plug stuff in and just do exactly what the formula says, is it pretty easy?
Wait,
Yep.
this says x1 plus x2.
X1 minus x2. Good there. Now guys, some of your points you're going to have are going to be with negatives. So when you subtract a negative, that's the same as what operation? Addition. So you want to make sure you're careful with that. I want to show you something real quickly. If I go back to the drawing. Do you integrate it from the point here to the point here? I would have to go backwards 3 and then up 4 to get there to form that triangle. So this is like a 3 value, right? Since I went left, it's like a negative 3. Agree with that? And then we went up how many units here? Check this out. Guys, within that formula, what was the 6 minus 9? That was negative 3. That was that value right there, right? And then we took that to what power? Second power, just like you did in the Pythagorean Theorem, right? Then if I go back to here, right down here, guys, what was the 4 minus 0? 4. Doesn't that represent this distance right here? And then you took it to what power again? Second power, okay? And then when you did all of that, you found this distance to be what value? Well, 5, right? 5, okay? All right, I want to make sure you have the formulas written down correctly. So go back here to example 4, right up top here. Make sure you have that written down exactly as I do, so that you have access to that. Are we cool with that? Everybody have what they need there? Okay. And then midpoint formula from yesterday. You have this one right here written down. Good with that? Okay. Well, I'm going to go ahead and end there. I'm going to get you the new assignment. Tomorrow's kind of looking like sort of a work day with stuff. I'm probably prepping you for a quiz that we're going to have on Friday. And